Alright, hey guys, so basically for today we're going to go on projectile motion. Everything's going to be about projectile motion. We're going to go for two parts, projectile motion and also free fall motion. So the main focus over here is not to get the final answer. It's how you want to get the final answer. All the steps, concepts and everything I'm going to reiterate and strengthen it in order for you guys to understand. Alright, in order to do that, let's have a look at the first example. Okay. What does this example read out? A projectile, okay, the moment they say projectile, you must know it's a curved motion. Okay. Okay, sure. So the moment we are talking about projectile, it's a curved motion. So let's continue reading this question. A projectile is launched from point O. Okay, selalunya dalam physics, kalau O ni adalah origin lah, it's macam maths, origin. Okay, let's say this is point O. At an angle of 32 degrees with the horizontal. Okay, kalau macam ni, tak pasti draw dulu dekat sini, Cartesian plane anda. So, O tu apa? Origin kan? At an angle of 32 degrees with the horizontal. Horizontal tu mendatar. So, 32 darjah dekat sini. Alright, 32 degrees towards the x-axis. Okay. It is thrown with an initial velocity u of 15 meter per second. Please bear in mind, initial velocity 15 meter per second. As shown in figure 2. Okay, selalunya figure tidak akan diberi, tapi if diberi, then you are considered lucky because you have some guide for you to answer the question. Just a moment. Alright. Okay. So now, when the projectile reaches point M, okay, point M dekat sini, what do you have to take note? You have to take note that point M bukan jatuh bawah. It is somewhere in the air. Nombor satu, it is somewhere in the air. Nombor dua, it is on the way down. Kenapa? Sini paling atas kan? It is on the way down. Okay, it's not on the way up. It's on the way down. Okay, now. When the projectile reaches point M, it is 2.62 meters from the ground. Maksudnya, here will be kosong lah kan, logic. Sini pun kalau M tu dia dekat jatuh sini, the object dah jatuh, dia pun kosong. Sebab kenapa? It's displacement kan, naik atas jadi positif, turun bawah jadi negatif. Let's say dia naik 1 meter, turun 1 meter, 1 minus 1. Atau 1 plus negative 1. Kenapa? Turun bawah is displacement negative. Alright. Now, they say 2.62 meters from the ground. Maksud dia dari sini sampai sini adalah 2.62. Maximum height, adakah itu 2.62? Bukan. Maximum height is this one kan? Which is capital H. See, logically boleh nampak kat sini. H adalah lebih tinggi daripada M. So definitely H is, maximum height is definitely more than 2.62. Okay. Itu semua dah ambil notice. Now, what do we do next? As usual, cara jawab macam mana? Stuva. Let's do the Stuva table, okay? X dengan Y. S, T, U, V, A. Alright, one by one. S untuk X component, do we know? Kita tahu tak cara dia apa-apa? Untuk X component. X component is anything like this. Tak tahu kan? Dia tak cakap apa-apa pun pasal tu. Jadi, just letak question mark. Senang cerita. Now, Y component. Y component dia bagi tahu tak? Yes, dia bagi tahu 2.62 meters from the ground. Tapi persoalan dia, adakah dia negatif atau positif? Dalam question ni, dia adalah positif. Kenapa? From the ground. The moment it's stated here from the ground, automatically 2.62 meters will be positive. Okay, dari bawah ke atas, from the ground. Okay, kalau it's going down, kalau dia cakap going down, then you put it as negative. Okay, next, time. Do you know time? You do not know time. Kenapa? Logic lah, dekat sini soalan dia suruh cari apa? Time. So, the moment you don't know untuk X, you tak tahu untuk Y juga. Kenapa? Dua-dua sama. Alright? Okay. What is the initial velocity? Okay, ini I think you guys are very familiar. Kita dah bincang tadi. Sini adalah 32 darjah. Sini dia bagi dah kan 15 dekat sini. There you go. So, X component, Y component boleh tak cari? I think it's quite obvious that you guys can find kan. X component apa? 15 cos 32. Y component apa? 15 sin 32. Okay. Now, final velocity. I've stated earlier, kalau untuk X component, you punya Ux equals to Vx. Initial velocity untuk X component sama dengan final velocity untuk X component. So, kalau initial velocity untuk X component 15 cos 32 darjah, final velocity untuk X component, adakah dia 15 cos 32 darjah? Yes, it's definitely 15 cos 32 degrees. Okay. Bear in mind, untuk Y component, your final velocity untuk Y component you tidak tahu. Okay, now before we move on, I just want to take a note over here. Dekat sini we are calculating at M tau, bukan dekat O, atau bukan balik kepada bawah. We are calculating at M. Sebab itu S kamu adalah 2.62. Kalau S kamu adalah kosong, then we are talking about the object dah mendarat dekat bawah sini. Okay, we are talking about 2.62 di atas udara. Okay. Acceleration X component. I think it's quite common that you guys know is kosong. Untuk Y component, apa yang effect? Gravity. Gravity value dia apa? Negatif, jangan lupa, 9.81 meter per second square. Okay. Belah kiri ada 3 info. Tapi the problem is, we want to find time. 3 info ni, let's have a try. Kita ada apa? V equals to U plus AT. Tengok sini kalau A kamu kosong, confirm tak boleh cari T kan? So you have to drop the formula. The A selalu akan kacau. S equals to UT plus 1 over 2 AT square. Sini juga A kamu kosong. So you have to drop the formula. Next. S equals to 1 over 2 U plus VT. Okay. Ini mungkin boleh cari, tapi you tak ada T, you tak ada S. Macam mana nak cari? You can't do it. V square equals to U square plus 2AS. Your A, you nak cari apa sekarang? T. You have AS UV. Tak ada T kat sini, so you can drop it. Okay. Remember to always label from X component. Kenapa? We want to know dari mana you dapat data-data ni semua. Kalau you tak tulis, most probably the markers won't know what you're doing. So, it will end up into a wrong atau misunderstandable answer. That is number 1. Number 2, kita tidak akan dapat markah untuk K1. K1, if they mark like this, means kefahaman. So, you have to label properly. From X component, okay, memang tak boleh cari, just leave it. Selalunya kalau tak boleh cari, tak payahlah tunjuk untuk komponen tu. So now, okay, you can write from Y component. Let's try the formula S equals to UT plus 1 over 2 AT square. S ada 2.62. U ada 15 sin 32 degrees. T kena cari. Plus 1 over 2, it's a value. A ada negative 9.81 meter per second square. T square kena cari. So basically you ada semua. Kena cari apa? T. Remember dekat sini, number 1, label from Y component. Itu method pertama. Kalau you tak nak, bolehlah you buat SY equals to UYT plus 1 over 2 AYT square. Tapi panjanglah sikit. So it's best for you to write from Y component, ambil data daripada Stuva table anda. And then you do it over here. Okay. Jawapan anda, okay, I think it's quite obvious sini T square kan. So dia akan jadi apa? Equation. So what you will get? You will get 4.905 T square minus 7.949 T plus 2.62 equals to 0. Okay, kalau solve ni melalui calculator, you akan dapat dua jawapan. Obviously because it's T square kan. You get T equals to 1.16 seconds. Number 2, you'll be getting T equals to 0.46 seconds. Okay. Now, Apakah beza all this stuff? We want to find, okay, M kamu, movement dia daripada O pergi atas and then is on the way down kan? It's on the way down. Jadi, first method, you can take the time, you test masuk dalam mana-mana formula dekat sini that you have. Tengok, dapat tak balik jawapan untuk komponen lain. Let's say, you leave V sebagai question mark. Maksudnya you tak tahu, buat tak tahulah. You fill in, A fill in, T you fill in dengan value yang dapat. Dapat tak jawapan untuk V? Kalau dapat, then definitely that's the answer. That is case number 1. That is one of the ways that you need to test when you have two answers. Selalunya T square, you'll have two answers. Number 2, kalau salah satu belah ada jawapan dia, let's say T equals to 1 and also T equals to -4. Okay, time tidak akan pernah jadi negatif. So you have to write bracket rejected. That is case number 2. Case number 3 is case macam ni. Case macam ni, how do you want to judge? You can use number 1 to substitute or number 3, which is 1.16 second. It is on the way down. Kenapa? We took the value of S 2.62. Kalau we want to take 0.46 second, it is on the way up. Macam mana saya tahu? Because I put the value Y 2.62 and over here it stated 2.62 from the ground. From the ground maksudnya it's on the way down, but remember it's not negative for displacement. Okay? Alright. But the best method is substitute lah. That is the most recommended method because in exams you don't have time to judge whether it's on the way down, on the way up and so on. Get the symbols right. Positive, negative tu semua betul. And then kalau tak sure, dia substitute balik, dapatkan jawapan. Alright. Do you have any questions before we move on to the second part?
Macam mana menentukan masa tu?
Okay. Nak tentukan masa, right? Okay. Let me just show you an example over here. Okay. Now, let's say you have sini T equals to 1.16 second kan? Okay. What you can do is, let's say I take over here you have your T, dah dapat T. What you can do is basically you can take V. No, you cannot take V sebab you tak ada V sini kan. You can take the same formula, UT plus 1 over 2 AT square. Okay. What can you do is S equals to UT plus 1 over 2 AT square, okay? Alright. So, what you can do over here is test the value. Maksud dia, T 1.16 ni masukkan dekat sini. Okay. S ni 2.62 kan? Yang ini, make it like you don't know the S. Anggap je you tak tahu S dia. You ada. Masukkan value U, masukkan value T yang you dapat daripada calculation. A, you masukkan value A, masukkan value T square daripada calculation. Dapat tak jawapan 2.62 yang ini? Kalau dapat jawapan 2.62, then that is the answer. That is method number 1. Method number 2 yang I cakap tadi is positive negative. Kalau negative, auto reject. Kenapa? Time mana ada negative, right? Okay. Number 3 is, okay, M kamu dekat sini kan? Is your M above? Yes, M is 2.62, clearly over here. 2.62 from the ground. So basically it's above the ground. Tapi, apakah motion M? Motion atau pergerakan M adalah pergi atas, lepas tu on the way down kan? When it's on the way down, it is 1.16. But when it is on the way up, going up like this, is 0.46. Okay, let me clear this up for you. Logic lah. Nak datang dari kosong sini sampai M, of course akan ambil masa lama, right? So, definitely it will take the longer time. But, to make sure your answer is correct, you should recheck. Macam mana nak recheck? Just right here, recheck, and then substitute the value like I taught you. Okay, do you get it?
Faham.
Alright. Okay. Now, let's go to B. calculate the horizontal distance of point O. B, calculate the horizontal distance. So, tadi kita dah cari apa? We are talking about still here, M from point O. Maksudnya dari sini sampai sini. Okay. Just a tip. Kalau tak boleh cari mana-mana komponen kan, first thing, best to cari time. Kenapa? Kalau X component time dah cari, kan dia sama dengan Y component. So just copy back on your Y component, then you will see that you have more information. That's one of the simplest tips for projectile motion. Okay. Calculate the horizontal distance. I think you get it because horizontal distance apa? Sx kan? Atau displacement bagi X component. So, what can you do? What can you do? You can just buat Sx atau you can put from X component S equals to UT plus 1 over 2 AT square. Kenapa ini adalah formula paling senang? Sebab A kan kosong dekat S component, dekat X component. So you can just cancel it off. But this is not the method. You have to show substitution. T kamu adalah tadi, what did you get for your T? It's 1.16. 1.16 square. Here pun 1.16. U kamu adalah 15 cos 32. You get 15 cos 32 degrees. S. Okay. Baru you tunjuk dekat sini. You get here 14.76 tambah kosong. You get 14.76 meters. Okay. Number 1, please label from X component. Number 2, tunjuk walaupun dia kosong, tunjuk juga. Number 3, unit kena betul. Okay. And then, number 4, untuk the whole projectile motion kan, jangan ever lupa change to SI unit. Let's say dekat sini millimeter. No, just make it easy, centimeter lah. So you have to change it to times 10 power negative 2. That is the simplest thing you have to do. Tukar semua pergi SI unit dalam Stuba table. Show your conversion, then you can start your calculation. Sebab kalau bukan dalam SI unit, then that is not physics. We want answers in 2 decimal places, final answers 2 decimal places, and also in SI unit. Alright, do you have any questions?
No.
Okay. Now, that is for the first one. That is projectile motion. That is memang pure lah. Soalan memang paling famous untuk projectile motion. Okay. Now, let's move on to the next question. Okay, this question, when you have a look at it, sebelum kita baca soalan tu pun kan, I think we can quite understand that this question we are talking about free fall. Kenapa? It's moving downwards like macam tu je. The movement of this thing is like this, settle. Sebab through visuals we can see that. But don't forget, baca soalan dulu untuk reconfirmation. Okay, so figure 1 shows a helicopter is traveling horizontally. Okay, traveling horizontally at 20 meter per second. The moment dia cakap traveling horizontally, apa maksud dia? X component kan? So, ada tak you punya value untuk X component? I think you guys might get it. Ada sudah kan? Now, let's continue. At a height of 50 meters above point B. Okay. Helikopter tu berada di mana? 50 meter above. Kalau dia cakap above apa? Y component. That is how you identify data. Data adalah paling penting you kena extract daripada soalan. Next. On horizontal ground when it releases a package. Maksud dia 50 meter above the ground, dia release a package. Okay. Yes, the helicopter is positive 50 meters above the ground. But the package is negative 50 meter. Kenapa? Package tu bukan travel dari bawah ke atas. Package tu is dropped, is released. Maksud dia akan travel dari atas ke bawah. So, definitely negative. Why? The movement is downwards. Okay? Itu paling penting. Now, let's move on to the question. How long will it take the package to reach the ground? Okay. Sekarang, untuk soalan yang berbentuk 1, 2, 3 begini, it's best for you to do separate stuva. Kenapa? Let's say soalan A dia cakap pasal package. Soalan B tiba dia cakap pasal helikopter. Luckily here they're talking about package. Let's say dia cakap pasal helikopter. Takkan nak guna stuva yang sama untuk package. Doesn't make sense, right? You have to use stuva baru untuk helikopter. So over here they're talking about the package, movement of the package. So now, let's go on and do our stuva, X and Y. X component, package, ada tak movement? Tiada. Sorry, label dulu ya, stuva. Time. Time, how long? Maksudnya time. Dia suruh cari time. Maksudnya tiada. Initial velocity Y component. Sini I think X component. Sini I think it's quite clear that we are talking about the package. Kalau dia cakap pasal helikopter, then betul anda boleh guna 20 meter per second sebab helikopter yang bergerak. Tapi package tu is just going directly down. The moment going directly down, initial velocity untuk X component tiada. As you guys know, Ux equals to Vx, right? Final velocity untuk X component, automatically none. Acceleration untuk X component pun tiada. So, we can conclude that this is a free fall motion. Jadi, hanya ambil untuk Y component. Alright? The moment we analyze and find out that we are talking about the Y component only, that is definitely we are talking about free fall motion. Basically just moving downwards macam tu. Atau moving upwards or downwards. Anywhere but only Y component involved. Now, how long will it take the package to reach the ground? As Y, I think you guys know it very well. It's negative 50. Because package reached the ground. It's been released, moving downwards. Okay. Next, time. You need to find the time. Next, initial velocity untuk Y component. Dia mula-mula berehat dekat sini. Ada tak initial velocity? Kosong kan? Ada initial velocity, bukan dia tak tahu. Dia berehat dekat sini. Bila dia mula release, baru dia ada certain velocity. Let's say 5 atau 6 meter per second. Tapi initial dia dekat mana? Dekat dalam helikopter tu. Belum release lagi, nak release tu. So, ada value dia apa? Kosong. Okay, next, final velocity. I don't think so you guys will know sebab we need to calculate. So we put it as Vy. Selalunya Vy perlu calculate. Most of the times, okay? Not all the time, please remember, not all the time but most of the time. Okay, now acceleration, I think you guys know very well, is negative 9.81 meter per second square. Okay, dah ada data. Let's try and calculate. Let's try to use S equals to UT plus 1 over 2 AT square. Alright, S, negatif, jangan lupa 50 equals to initial velocity, kosong. Time, you kena cari. Jangan risau, kenapa? We have another time over here. Jadi jangan risau langsung. Next, plus 1 over 2 A anda adalah negative 9.81 T, you need to find. Okay, what will you get? Your T over here, you will get 3.19 second. Okay, just a quick reminder, right? Just a quick reminder. Dekat sini, dalam buku, right? Sometimes they will put minus 1 over 2 GT square. Jangan risau, dua-dua betul. I recommend you to use AT square. Now, let me explain why. When you use negative 1 over 2 GT square, G adalah gravitational acceleration. Benda tu you will learn in chapter 7. Okay? Negative 1 over 2 GT square. When you use this, negative 1 over 2, your G must be in positive. Okay? Kalau you use negative 1 over 2 GT square, I recommend you to use plus 1 over 2 AT square. Kenapa? Number one, this is the original formula yang you belajar untuk linear motion. S equals to UT plus 1 over 2 AT square. Number two, tak kisahlah apa-apa jadi pun, just put plus 1 over 2 A negative 9.81. Don't forget your negative 9.81. Settle. Because positive negative akan jadi negative. That's why they just brought the negative out and put A equals to G. Alright. Okay. Now, after doing the calculation, you will get the answer t equals to 3.19 seconds. Okay. Do you have any questions before we move on?
Oke dah.
Alright, okay. Now, let's move on to the second question. When we are talking about the second question, okay, let me use purple color. How far from P? Okay, remember 50 meter above point P. Reread the question and relabel the diagram kalau tiada diagram. Dekat sini dah tulis dekat sini P, right? Jadi please make sure P is there. You know very well where is P. Next, how far from P will the package land? Okay. Sekarang persoalan dia how far, right? Not how high. Kalau how high, that is Y component. Sekarang how far? Dalam soalan ni, you have to click your mind. Masuk projectile terus. Kenapa? Sebab the helicopter is moving at a motion kan. Dia move straight. Tak logic kalau the parcel straight away dekat down. No, it will move somewhere like this. Pergi depan sikit, lepas tu baru jatuh. Sebab dia moving belah sini kan, baru logic sikit. Okay. Untuk soalan nombor 2, click your mind, X component. Ada. Alright? Now, let's have a go with the second question. Remember, you have to always be versatile atau flexible. Macam mana nak cara jawab. Okay. You have to do your stuva again. Kenapa ada X component kali ni? Now, how far from P will the package land? Untuk yang ini, your X component untuk S, you kena cari. Next, time X component you kena cari. Initial velocity. Alright, now back to the question. Figure 1 shows a helicopter is traveling horizontally at 20 meter per second. So, traveling horizontally kan? Jadi, horizontally itu apa? X component. So, when we are talking about X component, initial velocity of the X component is, kan dah ada kat sini, 20. Okay? Next, final velocity, I think you guys know, 20 juga. Tiada angle-angle. Kenapa? The helicopter is moving horizontally, 90 degrees. Okay? Jadi tiada angle-angle semua. Okay. Next, acceleration. Acceleration, I think you guys know, it's kosong. Kenapa? V minus U over T. V kamu adalah kosong. Sorry, 20. U kamu adalah 20. 20 minus 20, kosong. Next. Alright, untuk part yang ini, Y component it's not so necessary. Why? We need to find what is X. Itu nombor 1. Nombor 2, tak cukup data, right? I think it's quite obvious not enough data. Ada 3 je kat sini. Time ni, kalau you guys realize, how long will it take for the package to reach the ground and package land? Package to reach the ground and package land. Adakah itu benda sama? Benda sama. I think it sounds very similar, right? Package to reach the ground, package land. Basically, both is talking about the package hitting the ground. So, the time taken for the package to land is, you can copy back the answer, 3.19 seconds. Next, sekarang you guys can do your calculation freely. Let's try to use same formula, ut plus 1 over 2 at square. S kena cari. Jangan lupa, from X component, initial velocity 20, time 3.19, plus 1 over 2 acceleration kosong, T square, 3.19 square. Your S, for X component, you'll be getting 63.8 meters. Alright, any questions for this part?
No.
Okay. Now, Good, but please bear in mind, dekat sini, kenapa dia bukan negatif? Sebab the helicopter is moving to the right. Jadi, takkan package tu nak move dekat sini kan? Logic lah sikit. The package definitely will move forward sikit. So, it will land somewhere forward. The moment it's moving to the right, it's going to be positive. Alright, so positive 63.8. Now, let's move on to the final question. Let me just open up a new page. Okay, what does the question say? Calculate the vertical velocity. Vertical maksud apa? Y component kan? Okay. Soalan-soalan macam ni perlu pay a lot of attention because everything means data. When you have more data, the more safer your calculation will be. Calculate the vertical velocity of the package when it reaches the ground. Okay, sini pun cakap pasal apa? Reaches the ground. Maksudnya data kamu boleh guna time yang sama. Sebab first one reach the ground, second one landing, third one reach the ground. Everything is talking about the package dah jatuh dekat ground tu. Okay? So, as usual, do a Stuva table. X, Y component, S, T, U, V, A. Okay. Dekat sini, dia tanya apa? Vertical kan? Jadi, at times, you can take shortcuts. It's not shortcuts, it's like to make your life easier. Tadi dia cakap apa? How far. So, you know it's X component. That's why I didn't do for the Y component. To make your life much easier and faster calculation. Sekarang dia cakap apa? Vertical. Jadi, tak perlulah kisah sangat pasal X component. Buat dulu untuk Y component. Okay. Now, Y component, calculate the vertical velocity of the package when it reaches the ground. What is the Y component? The Y component for the package is negative 50. Next, time. Ada dah 3.19 seconds. Initial velocity. Over here, it's quite clear that, tengok, untuk first question, you guys did very clearly that it's kosong kan. Initial velocity is kosong. Same thing over here, initial velocity is going to be 0. Final velocity, okay, ini bukan X component, initial equals to final. No, this is Y component. So, you have to find. Sebab you tak tahu what is the final velocity. Sebab masa dekat-dekat nak landing tu pun, that is called final velocity. Basically, right before the impact. Itu ada speed dia. Usually, final velocity is the maximum velocity. Kalau dia suruh cari, what is the maximum speed of the object moving, that is usually referring to final velocity. Tapi, let's move on to this question. Acceleration, I think you guys know is negative 9.81. Okay, acceleration ada, initial velocity ada, time ada, displacement ada. What is the best formula? Let's say you use V equals to U plus AT. Usually, kita akan rujuk dua formula. Number one, V equals to U plus AT. Number two is S equals to UT plus 1 over 2 AT square. Kenapa? Nombor satu, V equals to U plus AT is the simplest ever formula to use. Jarang salah. Nombor dua, S equals to UT plus 1 over 2 AT square adalah formula yang selalunya people guna untuk cari displacement. Dari selalunya, these two are the most important ones. Now, let's move on. V untuk Y component, you have to find. Why? Sebab soalan suruh cari vertical velocity. When it reaches the ground. Maksudnya apa? Final velocity lah kan. Takkan dekat atas tu is final velocity. Jadi, initial dekat mana? Common logic. Atas tu initial, bawah final. Now, initial velocity kosong. Sebab dia dekat atas. Dekat helikopter tu. Plus A, negative 9.81. T, 3.19. Why? T ni adalah the whole journey atau the whole time taken for the parcel from up to bawah. Betul-betul jatuh. Okay? So, what you will get? You get negative. Jangan lupa negative, positive, negative. 31.29 meter per second. Alright. Dekat sini, I want to highlight. Sometimes, formula can be U minus GT. Same thing over here. G ni adalah gravitational acceleration. So, value untuk G adalah 9.81. Acceleration dekat sini, negative 9.81. They basically just took up the negative and put it over here. But it's best for you to stick to the original formula because you know very well acceleration in y component is negative 9.81. All right. Any questions?
No.
Okay. Do you have your own questions?
Tidak.
Okay. I hope you really understand. Okay. I would like you to do this. Could you just screenshot this question? This question would be your additional homework. This is number one. This question will be your number one question. Number two, I have marked your physics test that you guys did the other day. Tapi there's quite a number of mistakes that you guys do. So what I'm gonna ask you to do is, you guys have to redo your physics test 1. Practice makes perfect. Redo physics test 1, tapi only for the questions projectile motion and free fall motion. These two are the only things that you guys need to do. Number one, this question. Number two, redo the physics test 1, projectile motion and free fall motion. I'm not going to give you the answers again, I repeat. I'm not going to give you guys the answers. Why? Soalan dalam exam tidak akan diberi jawapan. Number one. Number two, I want you guys to be really confident in what you guys are doing. You guys know, okay, ini sedang berlaku. The tennis ball, the football is moving this way. The plane is moving this way. That is what we call physics. Imagination and how you relate your imagination towards calculation. Alright? Please bear in mind, physics is really fun if you understand the concept. That is good enough. Alright, any questions before we end this session?
No.
Alright, thank you very much for the day. And I hope you enjoy the session. Let me just stop recording right now.